Hello students, in this video we will factor trinomials that have a leading coefficient 1. Now let's start by multiplying some binomials. For example, x plus 2 times plus 3. And remember that when we multiply binomials, we multiply our first terms, our outer terms. Outer product is 3x. Inner product is 2x. I'm going to go ahead and add the 3x plus 2x to obtain 5x. And multiplying last terms, we obtain 6. Now I do want to consider all of our possible sign options. For example, if we multiply x plus 2 times x minus 3, and then we multiply x minus 2 times x plus 3. And let's compare those to x minus 2 times x minus 3. Just considering all of our possible outcomes when we multiply possible changes in plus and minus signs in our binomials. X plus 2 times x minus 3 gives x squared. Minus 3x plus 2x combined to minus x minus 6. Next, we obtain x squared plus 3x minus 2x combines to plus 1x minus 6. And lastly, x minus 2 times x minus 3 gives x squared. Minus 3x minus 2x combined to minus 5x. And that last product is positive 6. So knowing the different options for our outcomes, for example, here we've got a trinomial with positive symbols only. We know that we have to multiply two binomials that have positive symbols only. If our last term of a trinomial is negative, then we know that the signs are opposites with our binomials. Looking at the middle term will indicate which of those final terms needs to be larger in absolute value. If we have a trinomial with a positive last term but a negative second term, then we know that our binomials both have negative symbols. Now our goal in this video will be to factor trinomials of this type that each have a leading coefficient 1. And that means that our coefficient of x squared is 1. For example, if we factor x squared plus 5x plus 6, then if this factors, it factors as the product of two binomials, where we know that our first terms must both be x to obtain x squared. And now we also know that these are both plus symbols within the binomials because we've got plus symbols throughout the trinomial. And now our question is, what are factors of 6 that are going to give an inner and outer product sum 5? So we know that using 1 and 6 would not work because they sum to 7. But the factors of 6, 2, and 3 will work because 2x plus 3x gives 5x and 2 times 3 gives 6. Now let's continue and look at some examples in which we factor. Factor each trinomial completely. If the polynomial cannot be factored, we say that it's prime. In part A, notice that these are all plus symbols within our trinomial. And so we know that when we factor, to use plus symbols. X times x gives x squared. Now our question is, what are factors of 7 that sum to 8? Well, 7 is prime, and so we really have no options here. If this factors, we must factor it as x plus 1 times x plus 7. Now let's check that. As we multiply, x times x is x squared. Our outer product, 7x. Inner product, 1x. Those combine to 8x. And lastly, 1 times 7 is 7. as we factor, we're rewriting these trinomials as a product of binomials. In part B, we know our first terms are both y to get a product of y squared. We see plus symbols throughout, so we know that these are both plus symbols. Now our question is, what are factors of 12 that are going to sum to 11? Or excuse me, factors of 24. Can we use 1 times 24? No, that sums to 25. Might we use 2 times 12? Well, that sums to 14. How about 3 times 8? Those sum to 11, and there's a winner. Let's write y plus 3 times y plus 8 and check. We know our first terms multiply to y squared. Outer product 8y, inner product 3y, those sum to 11y. And last product 24. So this checks out just fine. Part C. If this factors, it factors as the product of binomials. We're our first term. So our question is, what are factors of -5 that sum to -4? Now 5 is a prime number. Its only factors are 1 and 5. We know to use differently signed terms in here. And we want to sum to -4. Therefore, we use negative with the 5 and positive 1, and then check. X times x is x squared. Outer product minus 5x plus 1x combined to -4x. And 1 times -5 is -5. Let's continue with part D. Factoring a squared plus 4ab minus 21b squared. So notice that we've got two separate variables here. As we factor, in the front, a times a gives a squared. Our terms in the back of these binomials must contain the variable b in order to obtain a b squared as we multiply those last terms. Notice that our second term is positive, our last term is negative. Since this last term is negative, we know to use differently signed terms. The product of a positive and negative gives a negative. Now our question is, what are factors of -21 that sum to 4? If we think about our factors of 21, 3, and 7 are good options. And if we use a -3 with positive 7, they sum to 4. So a plus 7b to a minus 3b. And remember to check. In part E, as we try to factor t squared plus 11t plus 12, we know to write t and plus in both of these because we've got all plus symbols. Now let's try our factors of 12. We might try 1 and 12. Okay, is that going to check? 12x plus 1x is 13x. That doesn't work, does it? You might try to use t plus 2 times t plus 6. 2 and 6 are as our factors of 12. Outer product 6t, inner product 2t sums to 8t. That doesn't work either, does it? You might try to use factors of 12, 3 and 4. T plus 3 times t plus 4. That gives our inner and outer products, which sum to 7t, not 11t. And here we've exhausted all of our factors of 12. 1 times 12, 2 times 6, 3 times 4, and none of them worked. This trinomial does not factor. We say that it is prime. Lastly, part F. Y times y gives y squared. Our last terms must contain the variable x to give x squared. We've got a positive product, yet a negative sum, and so we know to use minus symbols in both binomials. Now our question is, what are factors of 36 that sum to negative 15? And they're going to be the same sign, aren't they? 1 and 36, no. 2 and 18, no. 3 and 12, yes. Let's check. Y times y is y squared. Outer product, minus 12xy minus 3xy combined to minus 15xy. And lastly, we do obtain a positive 36x squared. Always check your factorizations. In example 2, we're going to factor each trinomial completely. We're going to look for a greatest common factor first, which you always want to do. In part A, we can see that each of our terms contain the greatest common factor 3 along with y squared. 3y squared times y squared gives 3y to the fourth. 3y squared times negative 9y gives negative 27y to the third, and 3y squared times 20 gives 60y squared. Now let's continue factoring. Now as you continue factoring, do not lose or let that greatest common factor disappear from the front. Keep it. As we factor the trinomial, we believe it's going to factor as the product of two binomials. Our first terms, y times y gives y squared. Factors of 20 that sum to negative 9 are minus 4 and minus 5. Check by multiplying. Part B, each of these terms has common factor 7. 7 times t squared gives 7t squared. 7 times 3t gives 21t, and 7 times negative 10 gives negative 70. And let's continue factoring if possible. Lose your greatest common factor. Let's see, t times t gives t squared. Factors of negative 10 that sum to 3 are plus 5 and minus 2. Again, make sure you check that by multiplying. There you go, students. In this section, we have factored trinomials with leading coefficient 1. And in each case, your question is, what are factors of that last term that sum to the coefficient of your middle term? Good luck with those.